Hello, everyone. We are here for the National Roadshow series in Norway. This is a hybrid workshop. Thank you, everyone, for joining. Let's wait a minute or so for anyone else that is joining online. You see in this first slide an overview of today's meeting, and I'll just move to the agenda while we're waiting. I guess we can start. Hello, my name is Vaso Kalaidzi. I work for DANS, and I am the project lead of the FAIR Impact project. I will offer a very brief overview of the project today to get you into the mood for what you're going to hear from the rest of the colleagues. And in this slide, you can see the rest of the agenda. So the FAIR Impact project is a project, apologies, I have a problem with my network, so I might need to stop my video temporarily, but I hope you can hear me. So here's our project in a nutshell. The FAIR Impact project is a 10 million euro European funded project. We have 28 partners and affiliated entities. It's a 3-year project, and at this moment, we are in the third and final year of its implementation. In this slide, you can see our team. These are the partners of our project, including some partners that we call integrated use case partners. These partners represent in our project a specific domain. But what does FAIR Impact do? In FAIR Impact, we identify ongoing, current, and emerging FAIR enabling components, practices, tools, and services across scientific communities, across research outputs, and at different levels at European, national, and institutional level. What we do and how we do it is through specific mechanisms that offer governance, coordination, and support for the adoption and implementation of these FAIR enabling solutions, as well as raising awareness. In this slide, you can see a little bit the structure of our project. I will start from what you see in the slide as work package 3, 4, 5, and 6. These are the main pillars of our project. These pillars represent work that is being done on persistent identifiers, on metadata and ontologies, on metrics, certification and guidelines, and a cross-cutting one that is interoperability. This work is supported and further coordinated by a layer of engagement, adoption, and implementation. The support that we offer in this project is mainly through this work package, project management, synchronization, and sustainability activities, as well as dissemination, exploitation, and communication. In this slide, you can see a little bit how we work across domains in the 4-pillar work packages on persistent identifiers, metadata ontologies, metrics, and interoperability. So the use case partners that we have that represent specific domains, those you can see on the right of your screen, on social sciences and humanities, photon and neutron science, life science, and agri-food. These use case partners, they provide their expertise in the project, in these pillar activities. But not only that, they also contribute to testing and they further contribute to adopting a solution working for one domain into multiple domains. They also enhance the project's collaboration across disciplines. First of all, I mentioned coordination and support, and the synchronization force is one of the mechanisms that we use for coordinating such activities between our project, FAIR Impact, and relevant EOSC and FAIR initiatives. We do so across the 3 years of the project through the synchronization force, a mechanism that works exactly on that, on synchronizing activities across the pillar activities of the project with other initiatives. We do so especially with a circle of workshops per year. These workshops have a starting session, sub-workshops per activity, so one for persistent identifiers, metadata ontologies, etc., and the closing session. If you go to our website, you can see the 2 previous editions of the synchronization force and the relevant reports. And of course, at the moment, we have a synchronization force 3rd edition, the 2024 edition, that is ongoing. It started on September 3rd, and the workshops will continue until the 7th of November, with a final report and a white paper expected towards the beginning of 2025. Furthermore, in FAIR Impact, we have what we call the FAIR Implementation Catalog. This catalog is used to collect FAIR enabling solutions across domains, across activities, and across research outputs, as you can see here. I would encourage you to visit our website and the FAIR Implementation Catalog in order to see these solutions that are, in several cases, also used in our support program. Where do we stand now? As I said, this is the final year of the project, the 3rd year of the project, and we are closing our activities in May 2025. So far, we have worked and submitted 11 deliverables, 35 milestone activities were achieved, as well as several other materials that you can find on the website, such as use cases across domains, event materials, opinions, responses to the European Open Science Cloud task force papers, and all these you can see in an updated website view. I would also encourage you to visit the documents that we have and take a look at our 2nd policy brief. In this policy brief, you can see how the FAIR Impact project contributes to the activities of the strategic agenda for the European Open Science Cloud at the moment. Across this year so far, we have collaborated and we keep collaborating with several EU-funded projects in the EOSC and FAIR ecosystems, while at the moment we are placing our focus more and more on the sustainability of our outputs and how these outputs further contribute to the implementation of the EOSC. Engagement, adoption, and implementation are a core activity for the project. These activities are those who ensure the uptake of the proposed solutions and that support organizations in FAIR implementation. Here you can see an overview in this slide. It might seem a little bit too much, but take your time to read it. You can see the different rounds of support that we provide in the project and what we have done so far. The ways that we provide support are different per type of organization or of stakeholder, but also depending on the needs of our stakeholders. We provide, first of all, financial support. This is done through cascading grants, so through open calls. We also do that, we provide support also in kind. By in kind, we mean support, again, through open calls, but in the form of personalized support through effort that we provide and guidance to the applicants. We also provide open support through FAIR implementation workshops that are publicly available to anyone that is interested in implementing or in knowing more about FAIR enabling solutions. I would like to draw your attention on this slide on the top right. The final open call for financial support will launch on September 30th. You can find more information about whether you are eligible and what that means when you apply for such a call, and whether and what exactly to expect when you're selected. If you visit our website, you can look for open calls, and then you can find all this information there, including an FAQ section. In case you have any questions, you're interested in learning more, please do not hesitate to contact the project. Here I would like to encourage you to visit our community on Zenodo. You can find all of our outputs so far, publications, presentations, events, posters that we submit in conferences. And apart from that, on our website, you can also find some outputs that we regularly put for community review. So make sure you keep in touch through our website, through our activities, and as always, you can contact the project for further informations on the support that we provide, but also for opportunities for further collaboration until the end of our project. I would like to stop my presentation here and turn on my camera again. I would like to thank you very much for the time that you allowed me to give you an overview of our project, and wish you good luck and enjoy the rest of the workshop. Thank you very much.
All right. Thank you. We will be now switching to the speakers in the room. So just bear with us for a second while we're doing that. And if Camilla, you can share your screen.
Mm-hmm.
Okay. Okay, so you can hear me in the microphone here. Okay. My name is Camilla Hagen-Blixa. I'm a PhD student in neuroinformatics here at the University of Oslo. And I'm here today also because I'm a FAIR champion involved with the FAIR Impact project. So when I became a FAIR champion, they reached out and asked if we could do a national roadshow here in Norway. And I, of course, wanted to join in on that. And here we are. So my discipline is neuroscience. So I will talk a little bit about interoperability within neuroscience, how we deal with brain data in the eBrains data portal, a portal for neuroscientific data, and how we use a knowledge graph and 3D atlas models to improve interoperability across multimodal data output from various methods and techniques used to study the brain. So I have somewhat more specific question for today's talk. how to make open rat brain data interoperable, utilizing a knowledge graph and a 3D brain atlas. So this is the use case for today. But first, to give you a short introduction, in 2021, 43% of the global population had a condition affecting the nervous system, leading to death or disabilities. The human brain is intrinsically complex, so we want to understand and treat the brain, of course. But to do that, this is one way to do it. We can study the normal and diseased rat brain. We can do that with a range of techniques, resulting in different types of data. And when these data are submitted to be shared in the eBrains data portal, the data creation team will go through it. And this is where I come in. So this is me. I like to draw. So I have worked as a data creator since 2017. I've contributed to building the eBrains knowledge graph and the eBrains research infrastructure data portal, and used 3D brain atlases to make data more interoperable. So I will briefly present some definitions so you may know what I mean when I say interoperability from my point of view. Data interoperability refers to the ways in which data is formatted that allow diverse datasets to be merged or aggregated in meaningful ways. It is a key aspect of the FAIR data principles, constituting the I in FAIR. And these are my other two key terms for today. Knowledge graph. Knowledge graphs put data in context via linking and semantic metadata, and this way provide a framework for data integration, unification, analytics, and sharing. So we have the nodes or metadata terms, the entities, and the edges represent the relationships between the metadata terms. And brain atlases provide spatial references systems for neuroscience data that allow navigation, characterization, and analysis of information based on anatomical location. So these 3D brain atlases that we use have defined coordinate space and defined terminology. And because this is where my motivation lies, I will talk a little bit about why we're doing this. In a perfect world, researchers and data creators make sure to treat research data as valuable research outputs and make sure they are available to the scientific community to be understood and reused. Also, making sure they are indexed in relevant search engines. And this way, researchers may find and use data that they find in the cloud together with their own data. If these data from different sources are interoperable, it is easier for us, of course, to put them together to better understand the brain. Right? Something happened? Oh, okay. I will try to reshare. I will try to reshare. Okay.
We do want to see all these nice drawings.
Okay, let's try again. Maybe something like that.
Yeah, perfect.
Okay. However, there are many obstacles still for us to tackle, such as improving the interoperability. So what have we done to improve interoperability? To avoid data being dumped, in the worst case, in the cloud, we guide researchers in organizing their data, write a data descriptor, and use a metadata standard before we create a combined dataset. Datasets representing many different types of brain studies are made interoperable and linked together via common basic metadata, such as species or associated brain region. And this is what the graph looks like. This graph is organized by a metadata framework, OpenMinds, that provides metadata schemas for neuroscience in the JSON-LD format. And the datasets are made available in the eBrains data portal, a search engine. Yes, so to the other approach. Despite differences in techniques and data types, all data from the brain is associated to specific brain regions. We use 3D brain atlases, such as the Baxome Space Atlas for rat brain data, to define specific coordinate points and regions for each published dataset. And again, despite these differences in techniques and data types, we found that information about position in the brain came in 3 different categories: points of interest, images, or semantic descriptions. And we created a workflow to transform input in these 3 categories into a geometric object with a spatial position in the 3D atlas. And the geometric objects are defined in specialized metadata schemas. So this enables co-visualization and spatial analysis, and may be used to develop spatial search functionality for open brain data. And I'm hoping that we can create kind of like Google Maps, but for the brain. And that's actually something I'm going to talk about next Wednesday at the semifinal of Forskning Grand Prix here in Oslo. So come check it out if you want to. But to sum up, we use a node graph to represent metadata with nodes, and we use 3D brain atlases to represent metadata with geometric objects in space. And this is something we can do for all neuroscience data, despite the type. So perhaps not the perfect world yet, but in eBrains, we increase the interoperability of brain data by creation and integration of data into a knowledge graph and 3D brain atlases, depending on the species, to help us understand the brain better. Yes, and I would like to thank the people behind the eBrains data portal. It's a collaboration between different institutions in Europe. And these are also the people who have developed the workflows together with me and my team here in Oslo. Yes, so thank you.
All right, great. Thanks so much, Camilla. And we are moving on to Hitler.
Okay.
Hello, everybody. My name is Hilde Orten. I work at SICT, Norwegian Agency for Shared Services in Education and Research in the Bergen department. And I'm also in this context representing SASTA, the consortium of European Social Science Data Archives, which is an ERIC. So we are under SASTA in this contact. I'm also involved in different organizations that are focusing on metadata standards like the DDI Alliance and also the EOSC Semantic Interoperability Task Force, for example. And today I'm going to talk a little about a project that we were doing combining social science data from the European Social Survey together with data from environmental sciences, that is meteorological data and air quality. And I'm not going in detail about interoperability so much, but I will use this use case to highlight problems that occurred and solutions that we found. So how do I move on with this? Okay, so in the EOSC interoperability framework and also in FAIR Impact work package 6, where we are also involved, they are thinking about these 4 interoperability layers. Technical interoperability, that is that tools and solutions can work together. Semantic interoperability, that has to do with the meaning, and that the meaning is sent is the same as understood, both between humans and machines also. And organizational interoperability, that is, anything that has to do with interoperability between organizations, like we can start to collaborate, we have some common rules for the collaboration, for protocols we set up, for, whatever. So that has both a kind of semantic side and also a more, physical interoperability side. And then you have legal interoperability, which is also very important because you have to agree on which contracts to use, and it's good also to have vocabularies for that. And again, we touch on semantic interoperability, and all these things were kind of very nicely worked out in EOSC Future. I would say legal interoperability, that was for us never a focus before so much, but that project kind of highlighted that. And our project, it was called Climate Neutral and Smart Cities, and it was like touching on little simple problems, like if climate, or actually the environment in which people live, does it influence the interview responses? So here you have a picture of interview situation, and it's a very hot day. You can ask it if it has influence on what the respondent answers. And here you can see the contributors, here the partners. We were representing European Social Survey, ERIC, in this context, but SESTA ERIC also with the Slovenian Data Archive and the Swedish National Data Service were very much involved, and also on the kind of environmental science side where SESTA by S&D very, very helpful. And also from the ENRI consortium, we had IAGOS, which is a kind of air quality institute, which have airplanes that kind of capture measurements of air quality at different heights and locations. And also, because it was a little in the beginning difficult to get this organizational thing working, especially between the ENRI consortium before they saw we could do something together, then we contacted NILU in Norway and Meteorological Institute, and from there, hello, Lara. So that was also very helpful, and they were very helpful. And after a while, the ENRI got more and more interested and involved and helpful also. So it turned out very nicely. So I talked already about the objectives of this. And in addition to kind of the study, the relationship between responses and environmental factors, we're looking at data integration from different domains and what it might mean from a kind of metadata perspective and interoperability perspective in general. So here is where we are. When you come to a new domain, both people and often also machines, because everything is different, right? it is really, you have questions. What is this all about? You don't understand the definitions. Maybe you cover a geography differently. You represent it. You have different types of data file. You don't understand the methodology. What do this and that mean? And how is it represented? Where can we find the metadata and so on? Lots of questions. And that was for us also. So we were actually integrating, firstly making all this data interoperable or integratable, and that was really took some time and collaboration between the researchers to find out how to do this, and to find sources for this environmental data also. And we ended up with ESS data from 10 European cities. From 2016 to present, and then we added just a few variables about wind and temperature and precipitation, and also air quality of the kind of most common pollutants. And then we went on to kind of produce indicators about incidents of this that the response might have experienced. And then organizational interoperability. We need to get this collaboration working. And when we got that to happen, then we found out, okay, we realized also we have to document this in every detail what we do, because then others can kind of evaluate what we're doing, and people who are new to this can learn. So that was some work to get this working, but in the end it turned out very nicely. And here is the result. We downloaded thousands of data sets, and we kind of made them integratable by geography and time and so on. And then for the semantic interoperability of the hunt for metadata, as I call it, because in the European Social Survey, we are structuring data in a kind of granular standard called DDI lifecycle. That is a kind of social science standard, but it also has components that are very useful kind of for more domains also. So that was what we had in our system, so we used that. But for the other ones, it was hard really to find where the different components were, and we have to look around and dig out stuff and kind of manually input it ourselves. So this points to the fact that if everything was more more similar or same standards used, this would have been much easier. So now we published this in the ESS data portal. It's quite nice. As you see, you can look up easily what we have as data, little graphs and so on. And there are also, in addition to metadata at the study level or more minimal metadata, we have detailed description on the levels of the variables also for everything. So you can go in detail and see what we have. But then what about the workflows? We focused a lot on that, and since interdisciplinary research is not the norm, researchers from multiple domains, yeah, we need to work together, as I said, to have this, and then also granular information about provenance is needed. And that is very important for the reusability in FAIR. So what we did then, we used again a new standard called DDI cross-domain integration, or CDI, to make a little tool. And in that tool, you can basically see all the steps we had in the process, and to go from the kind of data download, the sources they came from, and what happened to them. And here you can see kind of a process step where we create a variable, and we can see all of the variables that were used to create it. And then the output, when you click on that, you come back to the other tool again, so you can see more about, and then how it is used in further computations. And then for everything, you can also click on a link to a script, and then you can see it in Python how it was computed. And you also have a human readable description about everything, so also people can really understand this without any technical competence, just for the methods and for verification and learning. And about legal interoperability, privacy issues were not addressed in this project because we kind of had bigger regions, so that was not a problem for us. We used open licenses as EU project kind of require that, MIT for code and CC BY for other deliverables. But we had a dispute again with the ESS team because they have non-commercial share alike, and non-commercial puts a limitation on it. So there again, it wasn't perfect interoperable, and we had to kind of document that separately. And for that, it would have been nice to have a kind of standard vocabulary that you could put. And I know in work package 6 in FAIR Impact about legal interoperability have been kind of working further on that. So that's very nice. And then we have IP rights and attribution. And that was the foreground, the rights of the project output was attributed to the contributing institution. We had again a discussion about ownership contract because the social scientists didn't want to have it. For the environmental scientists, it was no problem. They are used to it. But social scientists, no. So then it ended up in Euskuta that it not for results, only for deliverables. So then we managed to get out of that with an attribution to authors then. And the takeaway, that was that project had a very nice focus on interoperability in general, all aspects, and this collaboration among institutions and also experts from the different domains was a really nice and a valuable experience. And also that new focus on legal interoperability, I think, is very important. And for recommendation for metadata, we would say that granular metadata is needed for interdisciplinary use. It's not enough with a minimal metadata standard, and also focus on provenance and related tooling. And when I saw an article by Diego Scardaci and others from December 2021 about capabilities and gaps in the EOSC interoperability framework, I saw he was just there were many, they pointed at things like, okay, it is too domain specific, it lacks provenance, better standard definitions, and so on. So we are, I think, on the right track, and good that things are continuing in FAIR Impact and in other projects. So now I want to finish, but in the end of my presentation, I have some sources. Here you can read more about our little use case. Here you can read about EOSC interoperability framework and what's going on in W3P6 and the other work packages there. And also I'd like to point to some interesting and new cross-domain metadata standards initiatives. You have the DDI-CDI from the DDI Alliance, and also CDIF, which is a kind of cross-domain interoperability framework that has been started on the World Fair. And that is also very interesting. So, thank you.
All right, thank you so much. And I think we're switching to the online panelists now.
Yes, I should share my screen. Do you see my screen or?
Not quite yet.
A moment, now? Yes.
Yeah, now I can see.
Okay, yeah, sorry, it was weird. Should I start? Yeah,
Yes,
okay.
please, you can start. Yes.
Sorry. Yeah, so thank you for inviting me for this event. My name is Renato, and I'm here to talk a bit about interoperability aspects with sensitive data, more specifically on the two use cases of MBOE and SESDA in the UK data service. But first, just a quick primer on what is the sensitive data that we are talking about. And when we think of sensitive data, we are mostly thinking of personal and identifiable data. And this is especially important for the human sciences and for the life sciences, which are the focus of the two use cases here. But there are others, such as the commercial and cultural secrets, but we are mostly focused on the personal identifiable data. And this is necessary to reference this type of data in research, since we want to provide the reusable data sets, identifiable and everything. And these require the use of persistent identifiers, which are the strings usually of text that uniquely identify data pieces, and they are persistent so that they can be found, so that the actual reference to data objects can be found like in the future. I will start with the sensitive data lifecycle that was studied by the SESDA and the UK data service use case. This is the default, let's say, the most used process lifecycle for research data to be deposited and reused from digital repositories. I'll go through each one as this use case has studied how this can change for sensitive data. To start with the first half, we start with the data producers. This is the usual ways of producing data. And then from this data is being conceived into a data research data object, created, collected as per usual. But then the process starts to be more cared through for sensitive data at the initial steps of depositing and appraisal of the data for the deposit. And here you need to take special care of the terms and conditions involved to use that sensitive data. The provenance is very important to see where this data comes from without identifying the actual end users. The initial sensitivity assessment done by the depositors, so for the initial idea of why is this data sensitive, what can be done with this data, and the versioning model to decide if this data changed in the future so that we can identify the different versions of this data. Then it goes into the curation, which is when the actual repository team looks through this data, see what can be changed, what can be added, see if the metadata matches the repository specifications. For sensitive data, this might involve the anonymization of this data so that they can be deposited safely, or at least different versions of the data can be deposited so that you can have the original data and the anonymized data and so on. And these require further sensitivity assessments. Then through all these, then you have to add persistent identifiers to all the versions created. And to enable the discovery of this data, you have to assess what can be disclosed so that the data can be discovered through searches. Since a search requires some level of exposure of the data object. For access, this can involve different types of access. The access can be a direct access, as normally is done by open data. But for sensitive data, you may require safe rooms or remote access to the data so that the actual person accessing it cannot copy it or take it out of the secure environment. And this may involve something more complex, like the 5 safes approach. It's a good read for anyone interested of how to secure that data, how people can access it. Then on the reuse of the data after the access, it's very important to do some screenings of what is being meant to be outputted. so that the output data does not break the sensitivity of the original data. In summary, it's a very involved process between the depositor and the repository. There is a very careful selection of what data can be exposed for discovery. If it's a subset, if data has to be changed, a sensitivity assessment of the data is very important from the initial deposit all the way through every possible reuse of that data and exposure of outputs. And versioning control is necessary to identify the different versions of the data via persistent identifiers. In identifiers.org, which is the other use case that we are talking about, we hope to support this kind of process lifecycle in the different steps as it is implemented by the repositories. Because we don't require the repositories to behave in a specific way. They can implement the lifecycle as they need to. And identifiers.org as a resolver for data objects needs to be able to handle all of these. But I spoke a bit about identifiers, which is the Embol EBI use case. But to give a better introduction of it, our mission is to provide persistent identifiers to enable the consistent access of scientific data. So if you know scientific data can be identified through several different identifiers, you have DOIs, you have ARCs, and several others. I don't mean to bore everyone here, but the idea here is that with identifiers, you can use a single type of ID, and you can resolve to all these types of resolvers or the end URL of that data object. And this is done through two main services: the registry, which is a manually created collection of descriptive and access metadata. So with the registry, you can see a large set of data providers, and through the registry, you yourself can use it to access the actual data objects. Or if you don't want to use the registry, if you just want to resolve one specific identifier, you can use our resolver, which automatically takes the identifier that you want to find and redirects you or provides you information on the data object to the data object that you are interested in. For identifiers, we use compact identifiers. So this is our identification scheme. And a compact identifier is created of a prefix and a local identifier. So a prefix identifies a data collection, and the local identifier identifies the data object in that collection. Let's go through some examples so that you can understand it better. So N2T provides the ARC service, and this ARC service has a namespace in the identifiers.org registry, and that namespace is identified by the prefix ARC. And in the ARC collection, you have several ARCs with their own identifiers, which is a little path, as you can see there. So the compact identifier on the middle column identifies a specific data object that can be resolved into the URL on the right. And the same are for any other data collections. So you have PDB, for example, which is the protein data bank. And PDB has its own ID scheme. And using the PDB prefix and the specific ID of the data, you can resolve to the URL of that specific structure. And in this case, there are more than one actual URL for it, given the different data providers of that structure. And same for ArcID, which is actually a resolver in itself. So that's also available through the ArcID prefix. And you can use actual identifiers.org URLs for this. So if you put identifiers.org/the compact identifier, it's going to automatically redirect you to the best landing page. And by best landing page, we consider several criteria, mainly availability. So for example, of PDB, we do constant checks on the different URLs available, and we redirect you to the one with the best availability, and other criteria. To give the example of PDB, you can see the URL there. It's going to redirect you to the PDB website. So in identifiers.org for sensitive data, we have implemented the protected resources. And the idea of protected resources is not just address the sensitive data, but also address other types of protections. So we mostly consider that if a resource is going to require authentication, authorization to access, so a sensitive data in a protected repository, for example, is going to be a protected resource. But we have other type of resources that also have protections, such as those of limited access. We have one example in our registry that hosts its data in the cloud, and every access to that data costs them considerable amount. That they decided to impose access protection on those. So that is also marked as a protected resource for us. And these protected resources have a special label on that, on the entry, and additional information for the users, so that when the user tries to access one and is blocked because it never accessed it before, they get a little bit of information on how to access it, what URL to check for more information, and if necessary, if this is not provided by the actual data provider, then an intermediary page is rendered. Just to quickly see, when you make a request for a prefix on identifiers.org, which is free, by the way, if you have a data collection and you want to make it more fair, it might be a good idea to have it on identifiers.org. This information is already requested. And then the idea of this implementation is to be as more general as possible, because we have namespaces in different subjects, not just life sciences, from this institution in different countries. And as the previous presenter said, it's very difficult to find the common ground between different communities like that. And also, you want to be as lightweight as possible, because identifiers.org is always a middleman in every communication. So we cannot be a middleman that takes too long to act. And of course, this is a very simple implementation, and we are open to expand it as more information comes up on protected resources. For future challenges, I think I'm running out of time, so I'll quickly we are just trying to be as more interoperable as possible. We are one of the core interoperability resource for Helix here, which is the European network, and we have different targets on how to make this more fair, but we are open for more discussion on this, of course. A little bit of acknowledgements, and the sources of the information is a very nice read from the partners of the CESDA UK data service on the life cycle. I explained it very briefly, but they have a few documents out for that. Thank you. This is my contact. Feel free to contact me if you have any questions.
Thank you very much, Renato. Thanks to all the speakers today. And the first part is ending here. Now we are going for a short break. We will have the second part from 2 to 3, which will be a first 15 minutes of wrap up with Camilla. And after that, there will be the session on reproducibility discussion with Agatha from the University of Oslo. So we reconvene at 2. And thank you for now, and see you in a bit.
Thanks a lot, and see you in a bit.
Hello, everyone. Welcome back. It's 2, and we are about to start the second part of the webinar. We'll give the floor to Camilla for a 15 minutes wrap-up summary overview. And for the key start of the discussion time that will follow later on. Thank you, Camilla.
Okay, thank you. So it was very nice to hear the presentations. So I'm ready to discuss together with you, but I'm first gonna briefly sum up what have been presented. So first we had Vasu Kalatsi, project lead of the FAIR Impact project. So she was giving an introduction about the FAIR Impact project, which is a project briefly like supporting FAIR practices, tools, and services across scientific disciplines at both European level, national level, and institutional level. And she were reminding us about some of the activities that are going on this fall, especially the synchronization force workshops, which are workshops on different topics of relevance, definitely to people here, I think, about PIDs and metrics for fairness and and also a couple of others. I think there are like 7 or 8 of these workshops. And she also showed us a site that you can find in their presentation. And so there's this community on Zenodo where you can find a lot of documentation about what's going on. And the project, of course, is here to help implement FAIR practices in Europe. So if anybody is interested, you are very welcome to contact the project or me or other relevant people to hear more about it. So next up was myself. So my name is Camilla Hagenbliksson. If anybody has joined since then. I'm representing the eBrain's research infrastructure for brain data. And I talked about interoperability within neuroscience and how we deal with that by representing metadata as nodes in a knowledge graph and as geometric objects in 3D brain atlases. And then we have Hilde Orten working for SICT here in Norway, in Bergen, and also representing CESTA, the Consortium of European Social Science Data Archives. So SICT is the Norwegian Agency for Shared Services in Education and Research. And Hilde was talking about 4 layers of interoperability that they are working with, and specifically about a project called Climate Neutral and Smart Cities, and where they have asked are the attitudes and values of citizens in European urban cities affected by the climate in their city when they are sitting down and having the interviews. So this project, as I understood, was a collaboration between social scientists and environmental specialists. And they have collected data from different sources. And she was like focused on the importance of metadata standards and provenance to kind of make this all be interoperable. And then last that was Renato Luazaba, representing the EMBL EBI, a European Bioinformatics Institute. He gave a talk about sensitive data and persistent identifiers, talking about the sensitive data life cycle at the CESTA in the United Kingdom. And so CESTA, again, the Consortium of European Social Science Data Archives. He was talking about the importance of special access and careful selection of metadata that can be discoverable, and also some solutions provided by identifiers.org, who are providing these compact identifiers as a solution for persistent identifiers on different levels of access. So I'm very interested to hear what we are gonna discuss. And when I heard you, Hilde and Renato, talking about provenance and also licenses, we also use the CC BY licenses in eBrains. And also like the different levels of access. It was very interesting to hear how you had worked on that with identifiers.org, because at the eBrains data portal, we have sensitive human data. When we have that, and we have several like levels of access, like controlled and restricted. But then we have like on the data landing page, we inform the user that they can request access or that they have to log in, but it was very interesting to see how, and I would very much like to hear more about identifiers.org. And I will, we will move on with the Agatha to lead the discussion. Thank you very much for having me.
All right. Thanks so much for that, Camilla. I think we can just open the floor for discussion. And those of you that are online, you can post your questions in the Q&A. We'll see them and we'll answer them. So feel free to do that. Camilla, you mentioned the identifiers, and so maybe let's start from that last presentation by Renato, because I also had some questions about that, and I always like to bring the discussion to the very basics. Because I also have two hats of a researcher and a research support staff. And so if I'm a researcher and I deal with sensitive data, I do understand what it means to put data from my project in an archive with restricted access, right? Then people will apply for the access to that data. And the curators or these people that work at the archive, they can make that decision or they can contact the PI to make that decision, right? So my question is, what does it mean to have persistent identifiers for sensitive data, and how these persistent identifiers that you were talking about, Renato, how they are controlling access to the data? Because I think for just like a regular researcher that doesn't really work with data curation, that can be confusing. Like what's the difference between that kind of identifier in a nutshell compared to like a DOI identifier that just points to the data but doesn't have any special functionalities?
So it's quite a big question, I would say, but in general, the persistent identifier has two main objectives. The first one is the obvious identification of the data. So you want every data to be the same identifier, and this is especially important for knowledge graphs, as data can have different URLs, the same data, and they can have different IRIs, let's say. And then you have the resolution, and that's, I guess your question is more on the resolution side, on how do I get the data object from the persistent identifier And getting the data object from the persistent identifier in general is, how do I find that URL? And that's what DOI does, and that's what identifiers does. They both do the same. The idea that we want to, and seems to be the consensus, at least with the FAIR Impact partners and the FAIR Core for Oslo project, they do have the same idea that a PID provider should not handle the sensitive data, because the PID provider is not the person who are managing that data. And we don't want to have this kind of contest with the data repositories. So the PID provider usually is gonna well, that's what we are walking through, it seems, is that the data provider is gonna handle the access, is gonna handle the secure environment to access the data, the reuse of that data and everything. And the PID provider is gonna resolve to the data provider. So in the same way, we're still going to behave the same. Identifiers, DOIs, they are still going to redirect you to the website with the landing page or the data object or the metadata, whatever. And the resolution to a URL, to a web page, to a system that is going to handle that authentication. I hope I answered the question.
Any follow-up thoughts or questions on these identifiers from the room or from Zoom?
But just to say, I don't really see the connection between identifiers and access constraints, because they're two very different things. So it's whoever is publishing the data that is through the, of course, curation, that decides what's going to be on the page where the ID was. So if in that page there is nothing but just a sentence says, to access this data, you need to contact this person, that's up to the publisher and the curators of the data set. So the PIDs as such is not supposed to convey the access, I think.
Exactly. So this is exactly where my question came from, because then why do we talk about persistent identifiers specifically for sensitive data, right? If PIDs are not supposed to have anything with access control, then what's different about identifiers for sensitive data versus identifiers for any data? Renata wants to jump in.
So in persistent identifiers, there is the concept of kernel metadata. So that's the data that is associated with the persistent identifier via the provider, via the persistent identifier provider. And that's still an open subject, because there is no clear definition what should be in the kernel and what should not. And in identifiers, we do provide some metadata with our persistent identifiers. We do have the description of the collection, how to access the collection, and so on. And that's associated with the persistent identifier of that collection. And in identifiers, what we have done is to add the minimal possible metadata to all our entries. And for sensitive data specifically, we have exactly what sorry, I don't know your name, the person in the white and black stripes. Exactly what you said, that we have the instructions on how to access that data. Very high level human readable text on how to see it. And we also add a URL for the more information. So because usually there is a page describing that information. So that's the only metadata we add, and that's the only difference. Aside from a possible landing page, because some resources don't have a landing page, they just resolve to an authorized page, and that's not very friendly. So we do have an optional landing page for that resource also if necessary. I hope I answered. Yeah.
If you can speak up.
I'm just trying to understand. I'm not familiar with this concept. So it means depending if you're authorized and not authorized, you will access different metadata. I'm totally lost. Sorry. for my.
It's good to be lost.
It's good. We need to have someone, I think.
That's the kind of thing, at least for me, and from what I've seen, is that that's going to depend on the data provider. So if they think there is a little set of data that they can show, perfect. But there are data providers like the one that we have on our registry that just show unauthorized, and that's the only thing that you get when you go to one of the URLs. And that's the idea of the kernel metadata. So even if that's what the provider gives you, then you still have a little bit of information to go on if you need to.
But so basically, it could be also implemented in a DOI normal.
Yeah, but I think it is really like that.
Okay.
So the only thing that the resolution service is doing is that when you hit this specific URL, you get into this page, and then it's for you to decide what that page will actually show. So it could be a login, for example, with nothing else than just, or it could be an access or some minimum information or everything. So it's on the other side that is decided what you do and what you don't. So you could surely do the same, because the only agreement you have with you is that the page resolves.
Yes.
What is up to you to
Yes.
decide.
Okay, so then we got it.
So I think everything boils down all the time to the question, what's the difference between that solution versus the solution that you presented, Renato, versus regular DOI, right? Or is that clear at this point?
No, yeah, that was my question. Like, why do we need another one? One, we can't do it with a DOI.org. So that was my.
You need to have an agreement with the data site or others, so you can pick whatever.
Yeah,
result you
exactly.
want.
So
So,
now it's very.
and the identifier.org is
Yeah.
a nice one. You can
Yes.
do it with other handles and so
Yeah.
on. So
Good,
it's
perfect.
just a solution.
Thanks. It's much clearer.
Great. So if I'm a researcher and not a data curator, but I would like a persistent identifier for whatever page I put my the data on, Renato, can I go to identifiers.org and just apply for identifier? Can it be anybody or okay. So the answer is yes.
So, sorry, if I may, so the idea of identifiers is to be open resolution of identifiers. So if you have a collection, you can just apply for identifiers on the website, and that's totally free. And that's the idea, because we wanted to, the idea of identifiers initially was to be this kind of free and easy resolver system that people can use as persistent identifiers. And yeah, basically that's it. You can use which one you prefer.
Good? We all understand? Awesome. Okay. Moving on. Because another sort of mechanism for restricting maybe not access, but the ways of data reuse are licenses. And Hilda, you talked a little bit about the licenses. And at some point you mentioned something about the non-commercial license, and that was the European Social Science Survey, right? That has the CC BY non-commercial, CC BY NC license.
Yes.
And you mentioned something about the issues that kind of license can create. If you could say something about that.
Well, it's not, the ESS are very decided about that they don't want the data to be used for commercial purposes. So that is why, and in the grant agreement, I think it was specified that it could be used, but it was a discussion because we had then on the one hand the open data from Copernicus ERA5 and from European Environmental Agency, and we kind of computed variables based on those, and that could be shared openly without restrictions, but the ESS one had to carry the non-commercial, and so that was when we integrated these data. We first had the kind of prepared environmental data, and they had kind of just CC BY, But when we merged everything, it had to be non-commercial sharing. So it was a
everything,
little, yeah. Or it could be specified that kind of parts of the data are this and that, but that was how we ended up doing it. Everything, including some ESS stuff, was then non-commercial, CC by non-commercial share alike. That was what we kind of agreed. Also, we had a consultation with them, with a kind of person focusing on the legal things around this, and we ended up with that.
Yeah, so I'm really curious about like what are the consequences down the road for that, because we increasingly start getting questions from researchers about, if I choose non-commercial license, does it mean, for example, private research institutions will not be able to reuse the data that I put out there? Is it only public universities and public institutions? Some researchers ask, can, for example, private colleges or schools be able to reuse the data that I put out there with non-commercial license? Were those kinds of topics that you also discussed when you decided?
No, not really. That kind of requirement was there in the first place, so we didn't discuss the consequences of that, because it is decided, and for this project we didn't have the chance really to go in detail or question that thing. So I can't really say anything more about how the ESS is thinking, or what is really, how this is detailed in the specification or anything.
Because I'm
it
thinking
was
about that.
only a practical problem for us.
Yeah,
that it
because
was like
I'm thinking about that interoperability between organizations
Yeah.
that you also talked about.
Yeah.
One of the facets of interoperability, and if we put a restriction on the data for certain types of organizations to not be able to reuse it, like how that sort of speaks to that, the interoperability. And there are tons of non-public research institutes in Norway that I can imagine they're probably already reusing ESS data. I mean, it's such a rich data sets that a lot of different research institutes.
Yeah, but I think anyway, it's good to share. However this spells out, it's good to use a standard license,
Yeah.
and not to kind of make your own stuff all the time,
Yes.
because then
And are CC licenses still the best standard licenses to use there for data? Because that's also, and also thinking about interoperability, right? We don't really have really good commonly used internationally recognized licenses that were designed specifically for data, because CC licenses were designed for creative works, and then not all of the conditions there are maybe appropriate for data reuse, but the consensus still is that CC licenses are the way to go.
Yes.
I have a question. So if I understood properly, when you like do this kind of data fusion, you still need to have an agreement between people to choose a resulting license, or is, because I find this is really I'm very interested, because we have many data where we use different types, and at the end it's always a tricky question at the end, what will be the resulting license?
Yeah.
So I would like to understand a bit more what kind of mechanism is in place for choosing this kind of final license.
The usual thing is that each kind of data provider has a kind of condition of use page where they describe in more or less detailed what could be done with the data and how it should be shared. And I think it's fair anyway to kind of respect that, even if like some the Copernicus that didn't tinker around with the data and do everything with it like we did this project, that you kind of share these things in the same spirit that the kind of, but you don't need to get back to them and ask for that, because it's already specified, and very often, well, always for the data used is specified how you can use
But
it.
is there like automatic tools that could guide researchers? Because it's really difficult when you have different licenses to know which one should I choose at the end.
But I don't think you can really choose. So if you integrate data that have, say, 9 of 10, they have CCVY, and then the other one that is more restrict, you cannot bypass that. That is the one that is set in the threshold. And I guess there can be automated way, because if it is machine readable, the license, it will come into your workflow and say, okay, this is set in the threshold for the product that I have after integration. No, it's, and then I think it shows very easily that when you have quite restrictive license, it ruins sort of integration and further.
So we always go for the most restrictive license. That's the.
Yes, but still, we then also wanted to keep and if possible to have different parts of a collection with different licenses. So we kind of did that because we first prepared everything in blocks, and then they had more the original license, and then it's just the merge, and then they kept the strict, but you have exactly the same stuff in other blocks with a more open, so you can access it that way. And in the work package 6 of FAIR Impact, a work package has been focusing on this and looking also at vocabularies and the standards that can be used in developing tools. So that's very nice also that following up on this from EO's future, that work package 6 has been focused on legal interoperability, and it's Anna Sophia Fink and Olivier Rochon have been kind of coordinators of that. So you can read results. I think at the end of my presentation I had some further readings about work package 6, and there are.
And I think these presentations will be shared with the registered participants. I don't remember if that was anybody said anything about that, but
I think so.
I think so.
That would be great, so that everybody can access these resources.
Yeah, because this is under work package 7, right? And they should have some deliverables, and this can be one. Or at least the result.
So the last question on these licenses for me, that is a little tricky, and maybe we don't have an answer, but this is a very knowledgeable crowd. So so maybe it's useful to throw this question there. What if among all the data resources that I want to add to my sort of larger data set for reuse, what if there's one that doesn't have any license on it? Is that
don't use it?
don't use it. Is that the guidance? Or?
Then you need to contact the provider.
Yeah.
Because then you don't know what to do with it.
So I should contact the author of the data set.
I would say so, just from a common sense perspective.
Yeah, because I think a lot of people treat data that is out there online as just openly available. If it doesn't have a license, it means, oh, you can do whatever you want with it, but actually it's all rights restricted, right? If there's no license, it means that actually there are no instructions for reuse, so you actually shouldn't be reusing it unless you contact that. Go ahead.
Small curiosity or follow-up. So when you distribute together data from different sources, does that count as a remix, or doesn't it?
Well, remix, I don't know.
So like there is a CC license that one can state that you can't do any remix. So would that type of license prevent you from distributing data in this way, or it wouldn't, because you're just aggregating, you're not actually modifying it? Does that count as a remix or not? That's a curiosity.
Yeah, you can say that again. What we do is that we transform the data and make them available. And that is before we kind of merge them. This is kind of according to the what is specified in the agreement for the open data sources that we used you can not remix, but transform and kind of further develop them. So if you call it remix, I'm not sure about what you how you define that.
Mm.
Like if you modify them in any way, so you can share them, but if you touch them, then you can't. Well, that's how the type of license works.
Yeah, you can if you touch them, you can, but it's not them anymore.
Yeah.
You cannot publish them as Copernicus data, but you can publish them. If you understand what I mean, yeah. So that's what, then it is a remix, but it is not, we don't say that this is Copernicus data anymore. It is but the source of it is Copernicus. And then we have this provenance to where everything is described in detail and the code and everything. So you can follow fully transparent what has happened to the data.
Can you, Hilda, since you mentioned provenance, could you describe in very simple words what provenance is? I think I know it's pointing to the sort of original location or original source, but I also know that provenance is used maybe slightly differently in different contexts. So sometimes it's a little confusing. I don't know if you have like a go-to definition for that.
Well, in connection with data, you could actually say that it is how data originated.
Yes.
So you can have if you like, you can have the full life cycle perspective and all the steps, and what you can include in that provenance depends on the model. And if it is like we had like a descriptive provenance, that you go back and describe something that had happened, or like you have a system that can kind of drive your processes. So that are two different ways. But when you describe, you can start as early as you like, or you find appropriate. So where we started, when we got the data from the different sources, because we shouldn't describe what the others have been doing to the data, that you can read on their pages, because that's their data. We can describe the transformations that happened with us, and so on. You need to find out what is the level of detail that you would like, and also where to start and how to do it. But for reproducibility, it is vital. For reproducibility, you have to know.
So if I take a data set that has been already reused and remixed 5 times, and I'm doing it the 6th time, for example, when I indicate provenance, I still point out to that original source of data from 6 times ago, or do I point to one step behind?
I will say one step behind. Okay. Because otherwise you will lose everything that happened in between.
Yes. So provenance is
agree?
always,
yeah, I agree.
It's always where data originated when I took it.
So before you apply.
Before you apply your changes.
Yes.
Yeah. Okay. Makes sense.
And if you are the collector, this is my opinion as a kind of metadata person. So yeah, what makes sense, because that's you know what happened when you had it, and then if it's then badly documented, you cannot go back and tell what happened if it's not documented, or
Yes.
well, not well enough documented. You cannot kind of presume, I'm sure it is because of this and that. You cannot do it. Then you have to rely on the documentation of the others.
That's a great point, because for whatever reason, I thought that, I will reference to the data set that I used and change, but the provenance should points to whatever like the very, very, very original source was, but that doesn't necessarily make sense, right? So I think that's a nice
I
clarification.
guess in principle, it should be transported. It's 5 steps, but you will never
Yeah.
have that
No.
in reality. So your task is to take what you have decided is your data source. And if you find the provenance that is aggregated in there from the beginning to when you use it, of course, you can append to that if you wish, but you can't invent something that is not available.
Yeah.
So.
Any other questions around that? Or-
I have a question. So you mentioned a little bit about the descriptive provenance. So how you kind of store this information about the provenance?
Well, we developed this tool for the purpose, so that we kind of worked out things in discussions and used spreadsheet. And I must say it was a hell to keep track of everything, because all the relationships and all the definitions, how this builds on that and builds again on that, and things like that. So we had a process, but we captured it then in a spreadsheet because we didn't have the tool. But afterwards, when we got the tool, we have it now in XML, but it could be in DDI, CDI. You could have JSON, LD, or other representations also. But this one was done in XML, and we had it in XML, and then it showed. It is shown in the tool. This was not a super big project, but we tried to do something useful out of the money. So, but it wasn't very, very much funded and so on. But that's how. But if you have a tool, then you can also for capturing this, you can do it along the way.
Yeah, that's great.
Yeah.
Yeah, it's very interesting. I'm kind of like remembering when we first started out with all this neuroscience data. So we are not the data providers ourselves, but like just the data creators. And my colleagues were developing these metadata schemas. And in the beginning, we had like a data set, and we like tagging keywords for the different techniques and stuff. And now they're developing these like provenance specific metadata schemas to kind of have all the relationships represented in the graph. So it's really a complex
Yeah.
a thing that you can just like elaborate on.
Yeah. Yeah, it gets complex, but it's very good for reproducibility.
Exactly.
And for transparency, so people can evaluate everything you did. And the methods, and I think that is more and more important also in cross-domain research, because there is a lot of interest recently now in combining social data and environmental data. There are big projects like the IcoCities project and others, and there are new upcoming things that will start next year and so on. And yeah. What was I about to say about that?
So while
Yeah.
you're thinking, Camila, you mentioned your work on with the eBrains portal and with metadata. I was sort of curious, how much do you require researchers to follow your schemas and put things in there themselves, and how much you do it for them? So you work as a data curator, but you are also a researcher. And if a researcher comes to you and okay, I have this whole data set with brain imaging or similar type of data, what do they need to do to put the data in this type of like nicely controlled, curated archive?
Yeah, so we do this in different ways. But one way is if you're like an individual researcher with neuroscience data, you can fill out the request form to share data, and then you're already like giving some metadata. This is then like transported into like, we have one system which is like a metadata wizard, we call it. So some of the metadata will come over here, and you can also fill in like a web form, some of the metadata. But we also have like other solutions where you can code and create these JSON-LD schemas.
So the researcher
directly.
themselves, they don't have to, for example, name their variables according to your schema, or they have to, or you do it for them?
We will provide
will do
like
it.
the keys.
Oh my goodness, that's
And
like
then they fill out.
heavenly really situation. I think that metadata and controlled vocabularies are a huge barrier for researchers right now to interoperability. They're definitely not experts on that. There is a big threshold to actually learning and understanding the whole scheme. So if data curators could actually do it for them, I think that's
yeah, this
that's
is
a huge help.
the metadata framework that for neuroscience that is being developed continuously. And so another thing that we do, because we ask them to write a data descriptor. You have maybe seen data papers online, so it follows like this format of like technical validation, usage notes. And as a data curator, you will look at the data, and you will look at the metadata, and you will look at the data descriptor, and you will try to like enrich the different resources up against each other. So you will have the data descriptor, and if you find some terms that should be added as metadata, then and to the controlled vocabulary, then we can also request the metadata schema development team to include this in the schema. So it's kind of a continuous process of enriching the vocabulary. And we also have other solutions. So some organizations that we have had collaborations with, where the data curators will create kind of a adapted solution for the type of data that they provide, and make it even easier to get their metadata into the existing forms of the metadata schemas and integrate it.
Speaking of metadata, Hilda, you mentioned granular metadata at some point. Could you, maybe it's just me that is ignorant, but I would love to hear clarifications on that.
Yeah, it is, well, you have a kind of in metadata, it's when you talk about minimal metadata, it's very often about a kind of data collection or a data set, like provider, like collection method, and this and that. But then if you go a little, and then you also have a vocabulary, for example, the kind of different things that are in a brain, or different species, hierarchy of species, or response options in a questionnaire, and all those types of vocabularies. And then you have something in between that is more about the structure of these data, structures of the things you have, like you have variables, you have this and that, those things. And there are not so many standards that deal with that, but that is very useful both for reuse and reproducibility, to have machine actionable stuff on different levels, and also for provenance. For example, now we could, in this little tool, because we have this granular metadata for everything, we could call up those data and on a variable level, and say a lot of things about how this has been produced and the methods and all of that. And that was what I wanted to point to earlier, how important methods are in this cross domain. So when you have all this kind of details for everything. You can point to all these little different things and you can combine them and you can say something about them and their relationships very easily. And really you need that. You cannot only explain about these things on a very high level. So this institution did that and it's the collection method is that. That doesn't help you so much.
So our controlled vocabularies, granular metadata, would that be sort of the same thing or?
Yeah, that is a big discussion. Ontologists would say everything is an ontology. So that, and then you could say that a kind of structural standard like DDI or STM, actually in the statistics world, they are kind of mid-level ontology because it's not about the things, but it is about a little structural vocabulary where these things live. So that's what I can say about that. It is such a structural standard. It's more that you describe a data collection and relationships, and also provenance and stuff related to that. And these are very useful things, and I think they are needed. And also in this CD framework, the cross-domain interoperability framework that World FAIR is developing, it is focusing on granular variable metadata in the structure, as well as other standards like DCAT, more kind of catalog details, and also standards for representing these vocabulary like scores and things. So this is a very, very difficult topic, both to explain and to agree on, but that this level is useful. I don't think there is so much debate about that. Yeah.
Any other questions?
Both nested metadata structures are also part of this conversation, especially if it is from multiple disciplines, then maybe they have each one their own standard that needs to be preserved, will do a merge, so then you kind of end up with a nested structure in which you have blocks, and then maybe another blocks that describes the interaction or something like that.
Yeah, at least vocabularies from that standard. I think the more structural stuff would need to be mapped, but then the vocabularies you would kind of be able to kind of reference or include. But if there is a structure talking about different things, that would need to be mapped to that other standard. So that is the way it would work. And also interesting, if I could ask you a question, because it was also something about what are the datums, or you're talking, what are the datums, right? Many data, they are kind of numeric. We usually have numeric datums that can be quantified, but how do you do it when you in eBrains? You also have this kind of, what you have as datum. Do you also have picture segments or things like that?
It's usually terms.
Usually terms, okay.
So
terms,
like describing it, or it's like species, and then you have age, which is of course like numeric. But we often have like categories, like age category.
Okay.
So
so the kind of pictures and all this from the brain, that do you point to them? So you have
the images.
Yeah.
So these would be the data files.
Yeah. Okay.
And they are included or indexed in the graph together with the metadata that they are associated to. But stored somewhere else.
Yeah.
Yeah.
Any other questions? Okay.
I have a question about you talk about interoperability within your field, and then you talk a bit about interoperability in their field or multidisciplinary. Can you explain me what would be the difference in terms of I'm a researcher and I want my data to be interoperable but beyond my discipline. What do I need to do more than what I usually do? What is the difference?
I could give like a brief comment first. So a lot of our workflows, at least the data sharing one, I would also say is like interdisciplinary. So it's not like very neuroscientific, neuroscience centric. The atlas, the 3D atlas is of course very specific to the 3D brain atlases, but are concepts that are relevant for other atlases, but or could be used with other atlases, but are maybe not that relevant in terms of data.
But for instance, I would never go to this 3D atlas to find something because I didn't even know about it.
Yeah.
So when I'm not from the field and you are talking about interoperability, how do you make it possible when people, researchers don't even know what they should look for?
Seems to me at least one of the key points, for example, she has this very nice use case.
Yeah,
with
yes, exactly.
social science and then climate data. So for example, already if your variables are variables that belong to a vocabulary that she can look up and has a specific definition with maybe specific protocols and so on, she would be able, if she comes from social science, to go and check out what exactly your variable means. If you as a climate scientist use whatever other things that you either invented yourself or is restricted to your little community, it will be very hard for other people to figure out what that term means outside your field. So I think number one would be that. So having vocabularies that other people can look up. And for sure at another level, which is maybe not the semantic as such, but is file formats. Because communities use very different file formats.
Yes.
So as long as there are file formats that people can open in open source software, I think that's a big step. Because a lot of people maybe just write in formats that are not structured, or and then it becomes difficult if you just download a spreadsheet to figure out what's column and what's the yellow highlighted thing.
Yeah,
So,
we needed to download the NASA 2 Panoply in the beginning to look at the files and to get familiar with them. But that was because why these collaborations are so important. And for us, we really got it going when we got everybody interested from all the different disciplines, and then we suddenly managed to talk together because everybody wanted really to make this happen. And I asked, what are your methods? You are the expert in your field. I cannot do this. You must say what you do, and then we can implement it. And then we tried to describe it in a kind of language that was more understandable for us, but then keeping at the same time the kind of best practice as prescribed by the researchers from those fields. That was the idea. But also I put one also regarding interoperability, if kind of more organizations across domains are using the same metadata standards, that would also help to transfer on the technical side. It would help a lot because, for example, we had to dig out all the different metadata from here and there, and if it was like granular and interoperable, that would be much more easy.
I think so. On this one a bit, I agree that it would be easier, but I don't think that's the real way to go. I think what makes the standards interoperable is the possibility of mapping. So if you end up using one standard because you have, or several, because of different type of legacies, but this standard can be mapped to others, as many as possible, then that makes life easy. Because you will never have people using the same standard, because then
No,
it will become
but,
like.
if you map to one, that is the idea of CDIF, that you can map to one.
Yeah.
Rather than many to many, but you can map to one.
And how do you select one?
I guess everybody thinks that there is one.
Yeah, but at least you can engage in these type of projects. That's very fruitful. The more people who engage and the more different perspectives come in, the better the specification will be.
And I think it's nice also because when you have this lesson learned, then if you say, okay, there is this community that is also interested in the data that we serve, and then you maybe figure out, oh, there are these 2 or 3 things I could do better. Because we have had some real sort of feedback.
Yes,
So then
exactly.
it's easy maybe for you to provide that kind of information. It's just that we really never thought about it. So then you can start providing it further down.
And I think it will help newcomers, like students, because they have to learn from scratch too. That's
All right, we'll need to slowly start wrapping up. Before time is running out so fast. Before we do, I actually have one more clarifying question to Renato. Because I think the whole discussion about sensitive data and the interoperability of sensitive data that need to sit there sort of hidden with restricted access is really interesting. And you mentioned something that was called safe rooms. And if you could just tell us exactly, I know that there's this concept of data visitation, right? That you just look at the data, but you cannot download them. Is that what we mean by safe rooms, or is that something very specific that works in a different way?
No, that's exactly it. So the concept of 5 saves is the idea that if you follow the 5 saves, the data is secure. And not going to go into details of them because I'm not super familiar with them myself, but to enable the 5 saves, it's very common to have the idea of safe rooms, which for computer informaticians is the idea that the data is going to be enclosed in this environment and the person accessing it cannot download it. And that can be done physically by having the researcher going to specifically to the place. This can be done remotely with virtual machines and everything else. But that's exactly it. It's one of the guarantees.
Yeah, I think that's something that I actually haven't come across this term, safe rooms, before, but I think a lot of researchers would also be really interested in these kinds of technical solutions for safe access or visitation of the data. All right.
I would,
yeah.
oh, no, just quickly, I would recommend discussing this with the SESDA UKDS use case, because that's what they have. And there is a very nice page that I link on my slides, exactly on the 5 saves. So that will be a nice reading.
Awesome. Super useful, and we got confirmation in the chat that the slides will be shared together with the recording at the event page. For those of you who are at the University of Oslo and would like to join for other ReproducibiliTea discussions, we actually do have tea with us here. Today, I send the link to our landing page where you can subscribe to our mailing list if you would like that. For those of you that are not at the University of Oslo, but online, but would still like to follow these discussions online, we do have that in the hybrid setup. So it's always possible to follow online. If you would like that, feel free to do that. Thanks so much for joining for this discussion today and for our wonderful presentations that were preceding these discussions as a part of this roadshow. We are very appreciative of our guests for visiting us today at the University of Oslo and for all of you who visited us online. So thanks so much again, and hope to see you around. Thanks a lot.